Hello. Today's topic continues with statistics, measures of dispersion part 2, particularly the standard deviation. Again, looking at the syllabus, you can see we have to do the standard deviation and what's called the variance. Again, in the formula booklet, the only formula that you're given is the one for the interquartile range. So measures of dispersion measure how spread out a data set is, and the measures of dispersion are the range, the interquartile range, already covered in part 1, and today in part 2, the standard deviation. The standard deviation, notated by the Greek letter sigma, is another measure of dispersion of the data. It can be thought of as the average distance of each data point from the mean. In exams, you only need to be able to find the standard deviation using technology, i.e. using your calculator. However, you may use standard deviation later on in the course in your IA, so the formula is given here for reference. In general, a small value of a standard deviation for a dataset includes that the values are spread over a relatively small range clustered around the mean, whereas a higher value of a standard deviation indicates that the values of the dataset are more spread out around the mean. The variance is quite simply the square of the standard deviation, notated as sigma squared. For example, if x is the weight of student in kilograms, then the standard deviation, sigma, would be measured in kilograms, while the variance, sigma squared, would be measured in kilograms squared. So the standard deviation is useful as a measure of spread or dispersion of the data, but later in the course, when we do regression and probability distributions, we will use the value of the variance. In this example, we're given a set of data, the masses, 10 masses, and we're asked to find the standard deviation, the variance, and the interquartile range. And to do that, we will use the calculator. So, in menu, press 2 for statistics and start by entering the data. Go, check, I've got 10 pieces of data. There you go, we can see on the screen 10 pieces of data. So, if we press the F6, the right tab, and again, we will get to the Calculations tab, F2, press that. Okay, again we're going to press F1, checking first that the setup is correct. The data has gone into list 1, and the frequencies are all set to 1. So pressing F1 for one variable calculation, we will get our summary results. The top one is the mean, 66.6, and the fourth one down, called sigma x. So on the calculator, the standard deviation is called sigma x. As you can see, it's 3.98 grams. So to work out the variance, we simply have to square that number. 3.9799 squared gives us a variance of 15.8 grams squared. And to work out the interquartile range, if we scroll down, we can take the lower quartile and the upper quartile As you can see, the lower quartile is 64 and the upper quartile, Q3, is 69. So 69 take away 64 gives us the 5 grams, as you can see there. So we have 3 similar examples coming up now. In the first example, we're given raw data here, and we're asked to find the standard deviation and to compare it with the mean. So again, we're going to use the calculator to do those calculations. So calculator, exit, and exit again, and then tab right, F4, F1 to delete the list, and put in the new list. One, 4, 6, 1, 5, 1, 1, 5, 8, another 1, 5, 8, 1, 6, 1, 1, 4, 9, 1, 60, 1, 4, 7, 1, 5, 8, another 160, 2, 1, 6, 2, 2, 5, 2, 3, 8. Checking that we have 13 items of data. We do. F6, tab right, okay. F2, calculations, F1, 1 variable calculations. And you see the mean is 171.3 or 171, rounded to 3 significant figures. And if you look at the 4th item down, the standard deviation, 30.8 ice creams, which is quite a large number, indicating that there is a lot of variability in the number of ice creams sold each week compared to the average or the mean number sold. So in the second example, okay, we now have data in a frequency table. So we use the calculator again, but we need to put in frequencies this time. Again, if we first exit and delete all those numbers, and start by putting in the scores in list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and then moving across to list 2 and putting in the frequencies. 21, 9, 8, 7, 20, 13, 9, 6, 2, and 1. Agreeing that they match up. So pressing F2 for a calculation, but again pressing F6 to set it up first, scrolling down to the frequencies option, and we need to tell the calculator that frequencies are in list 2, so we press F2 to select list, and then we type the number 2 to tell it it's list 2. Like that. If we exit and do our one variable calculation by pressing F1, we will see that the mean score on the dice is 5.82 and the standard deviation of scores is 2.80. And that's quite a small number, okay, quite close to 0, suggesting that most of the points are close to the mean score, to the average score. So in this last example, this time we have a grouped frequency distribution, and we need to remember here that when we have data grouped in classes, we need to use the mid values as an estimate of the weights of these cats. So again, going to the calculator and deleting everything in list 2, and then deleting everything in list 1, we're ready to enter the data. So list 1 will be the mid values, so that will be 2.5, 3.5, 4.5, 5.5, 6.5 and 7.5, and then tab it across to list 2, where we enter the frequencies, 5, 19, 17, 5, 3 and 1. Okay, checking they match up. And okay, going to F2 to do a calculation, and then F1, remembering that I've already set the frequencies to list 2. So my estimate of the mean, I can see now my approximation for the mean is 4.2 kilograms. That's the average weight of the 50 cats, and the standard deviation of that is 1.1 kilograms, which again is pretty small, suggesting that most of the weights of the cats are close to the average weight, to the mean weight.